Good afternoon, everyone. Today I will talk about my top 3 favorite presentations and explain why I like them. I will also give one possible improvement for each speaker. My first favorite presentation was inactivation of malaria protozoa and heavy metal reduction in wastewater. I liked this presentation because it dealt with two important problems at the same time. That is, they are biological pollution and chemical pollution in wastewater. The presenter explained that malaria was still a serious global health issue and wastewater contamination was also increasing because of industrial activities. The main solution was AGTiO2. During the day, under light conditions, it performed photocatalytic oxidation and helped inactivate the harmful microorganisms. At night, in the dark, it performed reduction and helped remove heavy metals. I thought this 24-hour working catalyst idea was efficient and practical. One tip for improvements for this presentation was that the presenter could have explained the biological mechanism more simply, especially the connection between malaria protozoa and photocatalytic inactivation. My second favorite presentation was the fourth lead of MOSFETs, Kelvin-Stolz's. I liked this presentation because it used a strong hook. The presenter compared a transistor to a water faucet, which made the concept of control easier to understand. The speaker then explained the third lead MOSFET, the problem of common source inductance, and the Kelvin source as a solution. I especially liked the compared and contrast part. The third lead MOSFET showed ringing, fluctuation, and low current rising, while the fourth lead MOSFET showed more stable gate control and cleaner waveforms. This made the benefit very clear. One tip for improvement was that the presenter could have explained the oscilloscope data more slowly and told the audience to focus on VGS, VDS, and IDS. My third favorite presentation was computational approach of CTAB driven Maragoni flow nanoparticle self-assembly. I liked this presentation because it explained the difficult mechanism step by step. The presenter introduced nanoparticle self-assembly, CTAB, Maragoni flow, and molecular dynamics simulation. The wine tears example was especially helpful because it made Maragoni flow easier to imagine. The presentation was also strong scientific logic. It showed how surfactants could control surface tension and how Maragoni flow could influence nanoparticle self-assembly. One tip for improvement was that the methodology slides could have been simplified. Some simulation details was important, but they were a little dense for a short presentation. In conclusion, I liked these three presentations for different reasons. The AGTiO2 presentation had strong real-world value. The Kelvin source MOSFET presentation had the clearest analogy and comparison. The CTAB Maragoni flow presentation had the most interesting scientific mechanism. Overall, I learned that a good technical presentation should guide the audience clearly, use helpful examples, and leave one memorable message. Thank you for listening.